Read path, probably one of the most complex, topics, if you will. So let's first summarize before we, get started. Let's first summarize what are the things, what are the components we can potentially come across, in this read path. So the read gets triggered when we issue a select statement. So you've got select star from or select specific columns from a particular key space dot table name, where at least you'll have to give the partition key. Clustering columns are obviously optional. So obviously, the coordinator figures out, all right, based on the hash, and if it's consistency level 1, it looks at gossip and figures out, okay, you, the replica node, you need to give me the data. So what does the node do to fetch the data? That's precisely what we're going to talk about here. So the components in play are row cache. We want to make some initial estimates. What are the SS tables that may not have the data? So get rid of those. Then we want to find out slightly more intelligently what are the SS tables that are not likely to have data. So we want to eliminate those as well. So after the elimination process of 2 and 3, whatever are the SS tables that are remaining, you really don't want to touch them unless you are absolutely sure it contains the data, which is where the partition index and key index, those would play a role. Then you would want to find out, okay, now I have figured out that these are the SS tables that contain the data. I need to start reading the SS tables. Now the question is, from where? As part of the compaction, SS tables can grow significantly over a period of time. So you really don't want to read a large SS table sequentially. That makes no sense. So we should be able to jump in the specific location where my data resides, where I can find my partition or even an individual record, and then start reading in that from that location. So obviously for that, I'll need a lot of indexing. And meanwhile, I'm doing all of this. If the data gets updated in memtable, I need to make sure I factor that in as well. So these are the different components, and broadly, these are the steps necessary. So let's break it down and look at the individual steps. So when the read comes in, right, the first thing that Cassandra node checks is the row cache. Have I cached this entire data that the user desires in row cache? In other words, have I recently served this data? If I have, I might find it there, and then everything is good. No big deal. But row cache is by default disabled, and there is a good reason behind that. And that essentially is termed as double caching. Please note, whenever you read a file from any, file system in any operating system, the file is temporarily brought in the buffer cache, and the subsequent reads can be serviced from in memory itself. So you've got row cache. In addition to that, you also have the buffer cache, storing exactly the same set of data. So just to avoid a few instructions, few in-memory operations, you're really not saving anything. So that's the reason why Cassandra has row cache disabled by default. But this feature exists nevertheless. So if the data is found in the row cache, well, all good. You just return it back. Your read path is over. But if you do not find it in row cache, then you have a big question mark in front of you. I got all these generation SS tables, which is sitting on the disk, and I want to find out which contains the data. Or wait a minute, what happens if I flip the question? Instead of asking the question, what happens, or rather, how many SS tables contain the data? What happens if I ask the reverse question? What happens if I want to eliminate the SS tables that I know for a fact that does not contain the data? What would be the benefits, if I start thinking like that? Let's take a look. So what Cassandra will do is, it knows that it has these many SS tables to read from. Obviously, it's there in a directory. and that directory is represented by the key space and the table name. So it goes and takes a look in there. Obviously, there is a metadata in Cassandra's cache where it takes a look at, not in the directory. And it says that, okay, I have, let's take, for instance, 20 SS tables who are potential candidates to read from. Each of these SS tables contain a statistics file or a metadata file. Let me just refer to it as metadata. It looks into the metadata and finds out, okay, I'm looking for a specific partition. I know for a fact that SS table is sorted, ascending with respect to the partition key, the token. The token that I'm looking for is this token within the range of the minimum and maximum of this SS table. If it is, then there is a chance that the data is there in this SS table. I'll give you an example. Suppose we have the minimum token in the SS table as, if we assume that the range of long or the total set of tokens is 100, 1 through 100. Let's assume this SS table's minimum token is, let's say, 10 and maximum is, say, 25. However, the where clause, that partition, when I tokenize that, let's say it is 70, 70. Is 70 in range? No. So do you think this SS table will ever contain the data? No. So we don't even have to bother reading anything else. That SS table is discarded from the read path, of course. And by discarding, I don't mean delete, obviously. That's the first level of check where I eliminate the SS tables that I know for a fact that does not contain the data. While I've done this cursory check and eliminated set of SS tables, the next thing is slightly more scientific. Well, of course, eliminating step number 2 is also scientific, but this one is slightly more intelligent. Let's put it this way. Bloom filter. This is an algorithm, another hashing algorithm created by Dr. Bloom. The objective is it samples the data from the SS tables in terms of the partitions, etc., and it creates a hash. So what will end up happening is the incoming partition key acts as an input, and the Bloom filter responds back on a per SS table basis. The remaining SS tables you're going to consider, right, asking the Bloom filter, right, and say, hey, listen, I am looking for this particular token. Please let me know if this SS table does not contain the data. Folks, I have flipped the thought process one more time. I'm asking the question, discard the SS tables that does not contain the data. I am not looking for the SS tables that contain the data. That's not my objective. I'm discarding SS tables. So Bloom filter can come back and tell, yeah, these are the SS tables I know for a fact does not contain the data. So the way Bloom filters work is, it is a probabilistic yes, definitive no. So if the Bloom filter says this SS table does not contain the data, there is no way that SS table will have the data. SS table never, Bloom filter never responds back saying that yes, this is the SS table that contains the data. If it does contain the data, Bloom filter will say, I don't know, maybe. Probabilistic yes, definitive no. That's the way Bloom filter works. So step number 3 also eliminates the SS tables we know for a fact that does not contain the data. Statistics have revealed that by this time, we have eliminated probably 80% plus SS tables that we know for a fact need not be considered for this read, for this partition.